Hello again, and welcome back to another C++ tutorial for absolute beginners. In the last video we covered if statements, and I challenged you to just kind of play around with if statements, and hopefully you did. And if you had any questions, hopefully you asked either in the comments section of the video or on the forum at onestopprogramming.com. So in this video, as promised, we're going to go over more variable types and just kind of the fundamental idea of variables and how they're actually stored in the computer and what's going on at a fundamental level. But before I get into that, I'd just like to give you a heads up to where this video tutorial series is going to eventually end up. At some point I'm going to feel that I've covered the vast majority of everything you need to know for a beginner in C++, at which point I will stop making these beginner tutorials and start focusing on tutorials of just building a game that we will design together. And I will go through the important parts of making a game and actually design the game in a series of tutorials, so you can make your first game just kind of being guided by someone else. So that will be a really good practical way for everyone to learn or actually implement and learn what they've learned through these videos. So with that, let's get right into this video with variable types. So the variable types that we've covered previously have been int, char, bool, and float. And char, briefly, is a variable that can hold a character. So if we have char letter 1 equals a, and if we see out letter 1, we should just see A printed to the screen. That's exactly what happened. If we try to put B in there as well, it will only print B, because the char variable can only contain one letter at a time. So if you needed a string of variables, or a string of characters, you'd need to do one of two things, both of which we'll get into at a later point, probably even not in this video. But for now, you need to know that a char variable is a variable that can contain one character. For those of you who need string variables, I'll cover that eventually. Won't be long. It'll probably be in the next video. Okay, so now we have our char variable, and you frequently used the bool variable in our last video, so don't need to go over that much. That can hold one of two values, true or false. And then our integer variable can hold a positive or negative number. So if we have int num1, that can hold a positive or negative number. But are there limits to that? Is there a maximum number that I can put in there? And the answer is yes, absolutely. See, each variable type is a certain number of bytes. Bytes are they're the smallest unit of size on a computer. Like, you have gigabytes, megabytes, kilobytes, all the way down to bytes, which is like 1 byte is very small. And what happens is, when you create letter 1 and num1, you're actually creating a certain section of the RAM in your computer is being taken up by letter 1 and num1. And the type specifies how much of that RAM is taken up. So, with a letter, or char, it's only a 1 byte section of memory. So each char variable takes up 1 byte. That's why it can only fit 1 character, because it's only 1 byte. An integer takes up 4 bytes, so it can hold more information. But there is a limit to how much, to the maximum number that it can hold. And I'm just going to read it off and type it in just for the sake of you knowing exactly how big it is. So it's 2147483647, which is a very big number, and that is positive or negative. That's how big your integer variable type can be. However, you can make this an unsigned int if you type unsigned in front of it. And now all of a sudden, this can't be a negative number, but it's approximately that times 2 is the number that that integer variable can now hold. So it's a 4-byte variable that is unsigned. So if we tried to set this an unsigned int to, let's say, -1, it took it, but let's try to print it and see what we get. We get not -1. We get, that's actually right there, is the maximum that an unsigned int can hold. So it doesn't work if you assign a negative value to it, but if we assign it 1, works just fine. The other thing that you can do is you can make an integer short or long. So you can have an unsigned short integer. So as you can see, that still works fine with our 1, but adding the short, if you had, let's say you had to create hundreds of thousands of integer variables in a program, but you knew they would all be containing relatively small positive numbers. You could make them all unsigned short ints, and instead of 4 bytes for an integer variable, a short int is only 2 bytes. So you gain a little bit of memory efficiency there. Now you can also make a long integer, which has the ability to hold more information. So if you needed really large numbers, you could do that. So now that's pretty much the core concept of the integer variable. And the float variable is a little bit different in that it doesn't have a hard-coded maximum and minimum value. However, it is a 4-byte, or it is also a 4-byte data type, but it can hold a specified number of digits, which can be looked up in the documentation of C++. I'm not going to go into that because you really don't need to know it unless you're going to be playing around with really, really small numbers, really, really precise numbers with a lot of decimal places, or really, really large numbers. But if you are doing that, and you're worried that your float variable will not have enough precision for your program, you can change it to a double. Now, a double is just an 8-byte variable type, so it's twice as large as a floating point data type. So you shouldn't be creating doubles unless you need to, but it's twice as large and also twice as accurate. So it can hold approximately 15 digits of data, while the floating point, the float, can only hold about 7 digits of data. So that is pretty much the basics of every variable type you could use, and you probably will use in C++. With the exclusion of string, which is not a native variable type, that actually has to be imported and included, but we will get into that in the next video. Right now, I'd like to cover the importance of scope and visibility, which you may not have heard something about, but it is a very, very important concept to have a really good understanding of. So, if I create a function, let's say it's int num1, and I don't give it any parameters, and for now let's just return 0. And we're going to have it print, we're going to create a variable, we're going to call it int var1. We're going to set it equal to 4, and we're going to print it. So let's just call our num1 function from our main function, see what we get. So we get our 4, we get our 1. I'll add an endl here so it looks a little better. So 4 and then 1. So let's create int a number equals 10. Now instead of, well, I printed 4 instead of var1, well, that was useful. Okay, but instead of var1, which equaled 4, let's just print a number up there. Because, I mean, we declared it right here, then we're calling num1, so it exists, so let's see if that works. And it doesn't. Because, listen very carefully, because this is very important. Because as soon as you leave the main function, a number does no longer exist. It's limited to the scope of the main function. And when we go up to num1, we're no longer in the scope of the main function. And a good way to think of scope is everything in these braces. Everything in these braces is in the scope of the main function. Everything in these braces are in the scope of num1. I should really name that like function, func num1, so we don't get that confused. So everything up here is in the scope of func num1. So similarly, if after func num1 returned, if I tried to, let's say, print out var1 and got rid of this so we didn't get a compiler error there, it would not be able to print var1 because it will say it's undeclared, even though it's declared right here. And it will specifically not be able to print var1 because, unlike a number which exists after you come back from func num1, so if we replace that with a number, it will print 10, which is correct. So clearly, when func num1 is called, a number exists, but it's outside the scope of func num1, so it's unable to be used. It doesn't, func num1 doesn't care that a number exists because it's outside of its scope. And the same thing with var1, and as soon as this closing brace is reached, everything from func num1 is purged from the memory. It is deleted. It no longer exists. It's deallocated. So it just doesn't become anything. Like, var1 is gone. Like, it's completely gone. While a number, while you're in func num1, still technically exists, but it cannot be accessed because it's outside of the scope. So let's say you had a variable that you needed to be accessible everywhere in every scope. You can create it above everything, not inside any braces, and it would be available everywhere. We call that a global variable. So if we typed int a number, how about int a global number, and set that equal to 6. And then we printed a global number in both of our locations. Let's see what we would get. It works. We get 6 in both places because it's a global variable and that exists everywhere after it's declared. Now, it is strongly discouraged that you avoid declaring global variables at all costs. It's not efficient, it's not good practice. You should use other methods to kind of circumvent the rules of scope and visibility. But for now, it's okay, but please don't get in the habit of doing that, because there are ways around scope that I will learn, that I'll teach you in a much later video, because it's quite an advanced topic. But for now, only declare a global variable if you absolutely need to. Now, one last thing that I want to cover about scope and visibility is just the concept of, what if you have a bunch of variables with the same name in competing scopes? So if we declare a variable, a global variable, and we call it num1, we set that equal to 4. And then we change all of our other variables to num1 and set them to different values. What is going to happen? So let's just try it, and then I'll explain why what happened did happen. So let's just set this to 0, 1, and 2. So the order that they were defined, they will be incremented. So I'm just going to throw in a bunch of print statements so we can see exactly what the value of this variable is at all different times. So let's run it and do a little comparison here. 0, 0, 2, 1. Okay. So with our first print statement right here, it's 0 because num1 hasn't been declared anywhere else. It's 0. And then the next line declares num1 equal to 1. I actually want to throw in one more cout for the sake of argument. Okay. So we have 0, which is expected because it hasn't been declared anywhere else yet. Then we set num1 in the scope of the main function to 1, and then we print it, and we get 1. So it's thrown out the original global value of num1 in the local scope and made it 1. So now we go to func number 2, or func num1, we go back up here, and we print out num1 again, and it's still 0. It has not taken on the new value that we gave it down here of 1, because this is simply declaring a local variable in this scope of num1, redeclaring over this. So we set num1 to 2 in this scope and set it equal to 2. And then we print it, and that's correct, it's 2. And then we return to our main function with our return 0 here. We return to where we came from, which is here. And we print out num1 again, and it's 1 in this scope declared up here. So this is a reason why global variables really aren't that useful, in the sense that when you try to use them again, their scope and visibility is changed when you redeclare them. Now, if I didn't redeclare it, let's just say I set right here, instead of declaring it, I just said num1 equals 2, num1 equals 1. So there's a difference between what the last program did and what this does. The last program redeclared the variable as int num1. This is just saying set the value of num1, which should already exist, to 1. Let's see how that works. 0, 1, 1, 2. Now that is a much better use of a global variable, and instead of redeclaring it all the time, we're actually just using the global variable as it was intended to be used. But as the last example showed, it can get really sticky and messy if you accidentally redeclare the variable. Now, if I tried to redeclare a variable twice, typically that you would never do that, but it can be confusing when you have global variables like that. So again, try to stray away from it. If you absolutely need to, it's okay, but know that there will be a way to get around the rules of scope and visibility in a much more advanced video. So thanks for watching. In the next video on variables, I think I'll just do one video, a quick video on string, so you can use your string variable types, because I know a lot of programmers want to use that, especially with games and stuff like that. So in the next video we'll do strings, and then we'll move on to loops in the video after that. So thanks for watching. If you have any questions, post them in the forum or in the comments section, and I hope you enjoyed the video.